Hey class, so we did not get through all of the triple examples, and since those are my favorite examples of all time, I would like to do some in a video so that you can refer to these while you guys do your homework. We did talk about what the triples were. So again, the triples are just sets of three numbers that are going to hold true in the Pythagorean theorem. It's a shortcut, guys, that's all it is. It's a shortcut. So if I know that two of the legs of a right triangle are 3 and 4, then the hypotenuse is automatically 5. Something to keep in mind is that the last number of all the triples is always the biggest number, and that's always the hypotenuse. So this 5 is going to be the hypotenuse, the 13 is the hypotenuse, and so on. Okay? So just keep in mind, like I said, the last number, the biggest number, is always the hypotenuse. So the other thing that I briefly mentioned was that the multiples of the triples are also going to hold true. So in other words, if I have a 3, 4, 5, that's the base, okay? But if I multiply all those numbers by 2, I get 3 times 2, 6, 8, and 10. 6, 8, 10 is also going to hold in the Pythagorean theorem. Okay, so I could also do 9. 4 times 3 is 12. 5 times 3 is 15. I could do 12. 4 times 4 is 16. 20. Now, you don't have to memorize those. All you need to do is memorize the 3, 4, 5, and you can work backwards and figure out if something's a multiple of a triple. And I'm going to do that example in a second. So I like to write down, just in case though, a couple. So like 5, 12, 13. Let's multiply all those by 2. We get 10, 24, 26. Okay? Maybe multiply all by 3. Okay, we get 15, 36, 39. Let's just multiply these by 2. 14, 48, and 50. Just for you guys to understand that no matter what, if I have a triple and I multiply them all by the same number, okay, I end up with another triple. Okay, so multiply by 2, 16, 30, 34. And one more. 18, 80, 82. So all I'm saying, guys, with these is that not only do the triples hold true, but the multiples of the triples hold true. Okay, so now let's actually apply this into our triangles. My first one's easy. Look at it. The first one. What kind of triple is this? There's a 24. The hypotenuse is 25. Ding, ding, ding. Automatically, it's a 7, 24, 25. Okay? So automatically, it's a 7, 24, 25. I do not need to do the Pythagorean theorem. I can just say, hey, it's a triple. I know x has to equal 7. If I don't remember the triples, I could still solve for x by using the Pythagorean theorem. 24 squared plus x squared equals 25 squared. That's a lot of time. Okay, and a lot of people decide, you know what, I'm not going to memorize the triples. They end up doing Pythagorean theorem every time, and they lose a lot of time. They don't finish their quizzes. I'm telling you right now, straight up, triples are all over the ACT, all over it. The second one's a little bit different, guys. This is not straight up a triple. It is a multiple of a triple, though. So I like to call it reducing the triangle. I'm going to reduce the triangle. I'm going to find a GCF that goes into 16 and that also goes into 12. Think about it, think about it. That number is 4. So if I divide those numbers by 4, what do I get? Well, 12 divided by 4 is 3. 16 divided by 4 is 4. And what kind of triangle? If you divide by the GCF, it should unveil what kind of triangle I have. This is a 3, 4. It's a 3, 4, 5. Okay? So I divided by 4 to get these inside numbers. But on the outside, you need to multiply these numbers by 4. So I usually write times 4. It's a 3, 4, 5 times 4. So all I need to do to get x is take this 5, multiply it by 4. So I get x equals 20. Let's try that again. Here I have 10 and 26. It's not a triple, but let's see if it is a triple. How do I see if it's a triple? Divide by the GCF on the inside of the triangle. Let's see. 2 goes into both of these. Divide by 2. What is 10 divided by 2? It's 5. 26 divided by 2 is 13. Hey, this is a 5, 12, 13 triangle. Now, to unveil that it's a 5, 12, 13, I divided by 2. So to go back out, I need to multiply by 2. So my missing piece was 12 times 2. That gives me x is 24. Next one. 3 and 5. I know what a lot of you are thinking. A lot of you are thinking, oh, done, it's a 3, 4, 5. You're wrong. The 3, 4, 5 only works if 5 is the hypotenuse. 5 must be the hypotenuse. If it's not the hypotenuse, it's not a triple, okay? So this is not a triple. This is a trickster. It's not a triple, it's a trickster. So instead, what do? This is when people are like, I don't know, it's not a triple, I can't do anything. You're wrong. You can always use the Pythagorean theorem. Leg squared. So a squared, 3 squared, plus 5 squared equals x squared. 9 plus 25 equals x squared. 34 equals x squared. Square root that baby up. We get x equals the square root of 34. So guys, don't forget, the Pythagorean theorem is there for you. It can always work. And you could figure out all the answers to these problems just using the Pythagorean theorem. Okay, what do I mean? What does Miss Barrett mean? This is what I mean. If I went through and I did 24 squared plus x squared equals 25 squared, I would solve through and I would get x equals 7. I don't know about you guys. I think it's a lot easier just to look at that and say, oh, it's a 7, 24, 25. I'm done. Okay, that's the purpose of the triples. Let's go on, talk about another one. Here's some more triples for you guys. Okay, so just taking a look. First one, divide by your GCF. It's going to be 10. 50 divided by 10 is 5. 120 divided by 10 is 12. What kind of triangle do I have? I have a 5, 12, 13 triangle. It is a triple. Now I divided by 10 to figure out it's a 5, 12, 13. To get back to the side lengths, I have to multiply by 10. 13 times 10 is 130. And that's it. Moving on. This one's crazy. This one's seemingly crazy, right? Okay, guys, I have 13 over 2, 5 over 2. This might be a 5, 12, 13. Now, it is a 5, 12, 13, but instead of dividing, this time we're multiplying by 2, right? Because 5 halves times 2 is 5. 13 halves times 2 is 13. This is a 12, 5, 12, 13 triangle. But I need to make sure that I go back out and divide by 2. In other words, this answer is just going to be 12 over 2. 5 over 2, 13 over 2. It's a 5, 12, 13. Don't forget, guys, 12 over 2 is 6. So, in this case, x is 6. Uno más, one more. Cool. Again, I'm noticing that 10 goes into both of these. Divide everything out by 10. I get an 8. The hypotenuse is 17. Is this a triple? Yes, it is. It's an 8, 15, 17. Okay, I divided everything by 10 to figure out it was an 8, 15, 17. To get the side lengths, I need to multiply by 10. So 15 times 10 gives me x equals 150. Cool. There's the triples. That's how they work. All right, I'm going to quickly go over a couple word problems, and that should sum up the rest of the lesson that we didn't get through. So for the word problems, the first one says a ladder is 15 feet from a house of a building. It reaches a window that is 35 feet high. What is the length of the ladder to the nearest foot? So I like to draw the picture. Here's the house with a nice little window. That window is 35 feet high. And we have a ladder that's going up to the window. It's a really lopsided ladder, but that's fine. I'm not an artist. That's cool. All right, I know that the window is 35 feet high. I also know that the ladder itself is 15 feet from the base of the building. We're going to go ahead and assume that the building's built to code and there's a right angle right there. So we have a right triangle with two sides. We're just missing the hypotenuse. Easy enough, you guys. Pythagorean theorem. 15 squared plus 35 squared equals x squared. Okay, so 15 squared is 225. 35 squared is 1,225 equals x squared. Okay, so we get, when we add those together, we get 1,450 equals x squared. Square root both sides. All right, 1450. When I square root that, that's going to be 25 times 58. Crazy, crazy, crazy. But you end up reducing this to 5 root 58 feet. Now, something to keep in mind is this says to the nearest foot. To the nearest foot. So that means that in a lot of the word problems, they actually want you to get a decimal answer. So how do I get a decimal answer? You're literally going to type in your calculator 5 times the square root of 58. So 5 times the square root of 58 is 38.08. And it says to the nearest foot, which means we just want to round to the whole number. So 38 feet. So why do we get an approximation for the word problems? That's because if I said to you guys, oh, 5 root 58, that's hard to imagine what that number is. Okay, so for the word problems, usually you are going to type in your calculator and get a decimal or some sort of approximation. If it's just a straight up math problem, you're going to leave the exact answer. And I'll clarify that for you guys as we continue on. I'm going to do one more word problem, and then we can pick it up with the rest tomorrow. So here's the last one. Let's see. I'm going to do the baseball diamond. Baseball diamond is a square. Okay. Now it is a diamond though, so I'm going to draw the square kind of like this. That's a little lopsided, but that's okay. It is a square, so we have 4 right angles. It says that there's 90 feet between each base, so all of these are 90. It says find the distance between second base and home plate. So I don't know much about baseball, but I know that second base and home plate is going to be that line right there. I'm looking for this segment. All right, so what am I noticing? I am noticing that I do have a right triangle here. There it is. And I know that I have 2 of the sides, 90 and 90. I'm looking for x. So 90 squared, it's a leg, plus 90 squared, another leg, equals x, the hypotenuse, squared. So I get 8100 plus 8100 equals x squared. So that's 16,200 equals x squared. It does say that they wanted an exact radical form, so I do not need to approximate this answer. I'm just going to square root both sides. Reducing this, guys, this is 8100 times 2, obviously. So when I do reduce this, I am going to get 90 root 2 equals x. And that's it. Okay, so there we have it. Go back, look at the triples. Hopefully that made sense. A couple word problem applications. Hopefully this will help you guys on your homework. I'll see you tomorrow.